Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Winelect. Today we're going to be talking about Azure migrations through the lens of architecture. Today we're going to be continuing our series on Azure migration, and we're going to be still talking about assessments, but we're going to be focusing on architecture today. And architecture is one of those topics that is often overlooked in many respects, and sometimes it can be one of those things that people don't consider valuable. But I want to talk about architecture specifically in relationship to assessments and why it's important to do architecture, because architecture is going to help shape a lot of the planning that goes into your Azure migration projects, whatever those might look like. So we're going to first go into why we do architecture, and then we're going to be talking about different kinds of architecture. So as we've been talking through Azure migrations, we've been looking at different aspects of this. Now we're still on the second part of an Azure migration, which is the assessment. It's a big part of it. We talked about learning already and the various topics that you can learn to get familiar with Azure. And we're continuing on with assessments because what we talked about already is looking at discovery related to these different topics. And then part of the discovery process is not only discovering the way things are in an environment, but it's also about moving things into how they ought to be on the environment through a recommendation. And the ought to be is the part that's going to really inform the next phase, which is planning our Azure migration. So we're going to be looking at how do we get things into an ought to be state. And that is really where architecture is really important, because what that does is helps frame the Azure migration projects that we're going to be undertaking when we actually start to plan these things and actually start to execute on them. And there's a lot of things that we need to consider in doing these kinds of architectures, because they can get rather detailed in their implementation. And there's a lot of aspects to them. So we're going to try to talk about it from a high level first, and then try to drill down into specific kinds of architecture and why you might want to consider one of these different kinds of architectures for your Azure migration projects. So when we start to look at architecture, there's really three broad categories of architecture that we want to look at. Now, the first one is enterprise architecture, and you do a lot of discovery up front to define or understand what your enterprise architecture really is. And a big part of what we were doing whenever we do a lot of that discovery process is understanding the business value and the business drivers and the business processes that undergird what get implemented in technical systems. And a lot of the business drivers that go into defining this are not defined in software requirements or defined in things that are explicitly related to what gets implemented. Some of the business drivers are things like governance and security. And these kinds of things are important to consider as part of your enterprise architecture, because they have important implications on how you implement things in the cloud and on Azure. So we're going to be looking at enterprise architecture strictly from the position of process, people, and value that get delivered by technical architectures, which are the next category I want to mention. Now, the technical architectures take what is defined in an enterprise architecture and deliver it in a technical implementation. And that's going to be installing applications, setting up data systems, setting up network infrastructure, securing that, and everything that goes into making systems run. And those are the technical details that technical architectures define. Now, the bridge between enterprise architecture and technical architecture is solutions architecture. Now, what a solution architect attempts to do is understand the business context of something. It tries to understand the business drivers, the business value, and all the business processes. And it attempts to understand the functionality and capabilities that need to happen in order to make a lot of that enterprise architecture work. And sometimes included in that enterprise architecture is understanding the systems that are in play. And these systems are not specifically technical systems, but the systems that undergird the actual organization that are in play that might not be explicitly related to the organization. And they could be external or they could be internal systems, but they aren't necessarily systems that are defined by technology. And all of that gets rolled up into a consideration to focus on driving a solution to support a given problem or business case or something like that. Solutions architecture is really about trying to find potential outcomes in technical architecture that are driven by a lot of what we consider in enterprise architecture. And this is an important idea here because solutions architecture really stripes across a lot of different domains, and that's why it's kind of high level. And the scoping of a solutions architecture can be very focused on a single application, or it can be very broad if we're talking about trying to move an entire organization's network into Azure or something like that. These solutions architectures are primarily going to be looking at a problem and trying to come up with a solution that is going to be implemented through the technical architectures that we will talk about later. So there are different kinds of architecture that we can talk about, and these are more architectural domains, but I like to think about them in two different kinds of categories. And the first one is horizontal architectures. Horizontal architectures are architectures we can think about as layers. So these would be things like application architectures and software architectures and component architectures that relate to apps. Or we can think about data and information architectures as being that kind of middle tier. And this would be things like how data moves through a system or how information is organized. And then underscoring both of those, we have network storage and infrastructure architectures that are very important to ensuring that our applications and our data are running well. And these define discrete layers in our systems, and they have different domains as it relates to different technical disciplines within the whole context of IT. There are some architectures, though, that don't really fit into any one of these various horizontal slices, and these are what we might call vertical architectures, and they stripe across these various horizontal layers that we have here. And these would be things like automation, logging, and security. I need security considerations for application, data, and infrastructure. I need logging considerations for application, data, and infrastructure. And we need to have an architecture in our horizontal architecture that is going to be informed by our vertical architecture as well. So these are a way to think about the way architectures are organized. Now, when we think about moving systems into Azure or migrating systems, we don't have to define all these different domains. We need to define the domains that are relevant to the kind of project or the kind of systems that I am going to be moving into Azure. For instance, if I'm moving my big data analytics system into Azure, I don't really need to consider something like an application architecture, or I don't really need to think about software architecture. I really need to think about data and information architecture, though, because that's going to be very important to those kinds of systems. Storage architecture might be very important to those kinds of systems. So I really need to think hard about how those kind of architectures are going to be reflected once I start planning my migrations into Azure. Now, whenever we think about specific problems and how to solve those problems, that's what solution architecture really gets at. A solutions architecture is very focused on a specific problem that we're trying to solve, and it's really not trying to define a network infrastructure or a data infrastructure or an application. It's really trying to understand holistically across all these various technical domains how they might inform a specific problem statement that I'm trying to build out. And so a solution architect is trying to be broad in that sense, that it's trying to pull from all these various technical domains to build out a solution that will deliver a solution for a specific kind of problems. So that's how I would frame these kinds of discussions around architecture. And whenever we go into defining these architectures for our migration projects, we need to really define what it is we're talking about and really define an architecture that is really going to be speaking to that specific domain so that we can consider it accordingly. If you try to get everything on a single architecture diagram, it's going to get really muddied really fast. But what we need to do is be very specific about what we're talking about. I'm talking about a network architecture. I'm talking about a storage architecture. I'm talking about an application architecture. And we want to do that so that whenever we go to deploy to Azure, we are talking about things in very specific domains, and we try to focus on those problems while being informed by these other domains that might be tangential to it. Now, the first kind of architecture I'm going to mention here is application architecture. Now, application architecture is a high-level view of an application and its components. Now, this isn't getting into the weeds about how the the software is being built. This is actually talking more about the components of a given application that all work together to deliver an application and how it runs. And so this is going to be very relevant whenever we start talking about building systems on Azure, because a lot of these components are going to be the various systems that are in play for an application and how the application is used. So we're going to think about it in terms of what does our client interact with. It's going to be interacting with a WAF, and this is just an example. It's not necessarily the penultimate application architecture. There are many application architectures out there, but it's just talking about the components of that. So we have a client, a web application firewall. There might be a web tier. There's some messaging going on. We might have some middleware there, and there might be a caching system and a data tier, and some kind of remote services that we're considering. All of these are various components of the application that work together to deliver that. Now, application architecture is very important on Azure because a lot of the actual technologies that are being implemented on Azure are going to be expressed as one or more of these different components. For instance, a web application firewall, for instance, would be a component of this application, but that's going to be expressed as something like maybe an application gateway on Azure that serves that purpose as a WAF for this entire application. So when we talk about an application architecture, we're talking about the various components that go into an application running. Software architecture drills down a little bit more into one of those components to talk about the various code aspects of that. Now, software architecture is going to be important on Azure because it's going to inform some of the decision making as to what you might use to run a specific kind of component. So if we're looking at, say, this application here, if I see that this is running something like Perl, a Perl application isn't going to run on something like Azure App Services without doing something to it. Either I might have to rewrite this component to something that is natively supported by something like Azure App Services, or maybe I have to containerize it and deploy it as a web app for containers on Azure, or maybe I need to use Kubernetes or something like that. So software architecture is one of those important pieces that you have to consider whenever you're talking about moving software into Azure. And it's going to be important to think about this at the code level, especially if you're moving your custom code into Azure and you're thinking about what I need to make my code work on an Azure platform without having to use some kind of resource such as a VM, and I want to get away from that, or some case like that. Now, related to both software and application architecture is component architecture. Now, the differentiator between this one and software architecture and application architecture is this one is oriented around how different application components work together. And this might include aspects of software architecture and application architecture. But the point of this is to think about the various software components and how they interact with one another for given use cases or a specific use case. And this is looking at the chain of various kinds of things as they go through an application. And we're going to be looking at how the actual user experience or the data movement happens from one component to the next to the next. And understanding something along those lines might also help inform decisions when it comes to defining various aspects of a software running on Azure. It might be that some of the components that I need might be running elsewhere. They might not even be migrated to Azure. And so I might have to think about running a different software component in one place and another software component in another, and there's a handoff that has to happen. And so there might be some security implications or network implications that come from the components that I'm going to be thinking about in my component architecture. So this is very important to think about whenever we're going beyond the scope of software, but not getting to the holistic view whenever we're getting into something like application architecture. Now, moving into the second layer that I mentioned that is in our layered approach for horizontal architectures is going to be information and data architecture. Now, information architecture is the way that entities in a business relate to one another. So our information architecture is really going to be more about our entity relationship mappings and things along those lines. And oftentimes that is how we express that as an architecture, is by doing an ERM diagram We don't really care a whole lot about where they're stored or where those entities reside, but we do care about how they relate to one another. And that is really why we do information architecture, so that we can understand how different business units and how different business entities all interact with one another. And that has implications on how we design software and so on around domains, etc. And so understanding information architecture will be important in Azure if you're going to be designing systems that deliver information, but you want to make sure that the information will flow accordingly and be able to deliver the information appropriately for the systems that need it, or the users that need it, or the reports that need it. Now, in that same middle tier, we have data architecture. Now, while information architecture is more concerned about how information is organized and how it relates to one another, data architecture is more about how data flows and how data is moved through a system. And this has huge implications in Azure, because Azure has a rich ecosystem of various services and offerings that really support data architecture and all kinds of ways of doing that. So whenever you go to Azure, there's a lot of as a service offerings on Azure that are reflected in the offerings that will do different things like stream analytics, or maybe it's big data transformations, or maybe it's databases that are for analysis, or maybe it's just data storage. All of these different kinds of aspects are play into a data architecture. And more than anything, this is one of those things that almost always ends up in a architecture discussion, is how do I move my data into Azure? How do I do transforms on that data? And then how do I present that data in a way that can be consumed, be it through an API, a report, an application, or something like that. So data architecture is going to be one of those things that almost everything touches for these kinds of reasons. Now, it might be simple, it might be very complex. That just depends on the nature of what is being put on Azure. But inevitably, you need to think about data architecture, at least, maybe not information architecture, but data architecture is almost certainly going to be a part of any Azure migration project. Now, moving into that bottom layer in our horizontal architectures, we're going to be talking about network architecture. And network architecture is another one of those kinds of architectures that almost every migration project needs to have as part of it, because network architecture is the high level design of how a network is going to be connected together. And so this is where we're going to define the high level components that make our network function. So we're going to be looking at how our network is organized from the virtual networks that I deploy onto Azure, and how I'm going to connect all those virtual networks together. I'm going to be looking at things like firewalls and routing. I'm going to be looking at the way that these things connect together from on-premise to Azure, be it a VPN or an express route. And I want to be able to see that visually in a diagram. Now, I don't have to put every server that is going to be on the network on this network diagram, but minimally I probably need to reflect the various network segments that I'm going to be putting into Azure and maybe on premise, and show those and how they relate to one another, and then their IP blocks, etc. And then talk about the major components that are going to be in play to handle things like the security and the routing, as well as the interconnects between the various network segments and the various different data centers that I might be deploying my application workloads to. So network infrastructure is going to be one of those things that almost every migration project needs to consider, and would be one of those things that you want to do first in a lot of ways to try to help understand how the network's going to look and how things are going to be mapped out once they are deployed into Azure. Another kind of architecture that most migrations have, but not all of them, are going to be storage architecture. Now, a simple migration into Azure that's moving mostly applications with databases may or may not need a storage architecture to explicitly define it. But if you're doing some kind of data analytics workloads where you have a lot of different data paths for data to move through it, storage architecture is going to be a big part of that data architecture, because the storage architecture is going to define how the network and the various storage buckets that you're going to be putting data into relate to one another. And this would include things like not only the network kind of components, but it would include the various kinds of storage that you're going to be providing. Is it going to be a data lake, or is it going to be a file share, or is it going to be a blob storage, or is it going to be a database? And these all play into your storage architecture and how the storage relates and how things get synced up and how things are relating to one another between on-premise and Azure to Azure, and various components in Azure. So this might be something that you need to map out and put thought into if you're going to be doing a lot of different kinds of storage. If you're just moving a simple application, or mostly applications into Azure, that is, you're just moving apps into something like Azure App Services, and you're using SQL databases, and you're not really dealing with a lot of external storage, then this might not be necessary. But if you're going beyond that, you probably want to think about storage architecture and think about how that relates to applications, data, and network architecture. So infrastructure architecture is another architecture that I want to mention here. Now, this is different from network architecture, which concerns itself with how the networks that are going to be supporting workloads on Azure interplay and work together, and different from storage architecture, which is mostly focused on how the storage components all interconnect and work together. Infrastructure architecture is more of a bottom-up view of infrastructure, and it's concerned with how infrastructure gets deployed into an environment without actually trying to represent all of that particular infrastructure itself. So this is going to be talking about things like control planes and control networks and hypervisors and various things that go into making all of that work. So one of the canonical use cases for an infrastructure architecture might be something like a disaster recovery plan that you're planning on putting in Azure. In that case, you have an on-premise system that you want to deploy to the cloud and do a failover to the cloud in the event of a disaster recovery scenario on premise. And in that case, you have various infrastructure components that need to be in place to make sure that the virtual machines from your on-premise environment are correctly being replicated into Azure. An infrastructure architecture would show the relationships between the hypervisors on premise and the various components that are involved with that, such as the replication servers and the configuration servers in ASR if you're using that product, and then how that relates to Azure infrastructure and how that gets deployed over on the Azure side in the event of disaster recovery and when that happens. So infrastructure architecture may or may not be relevant to your particular context, but it is certainly going to be relevant to certain kinds of use cases on Azure that really need to think about different aspects of Azure that aren't explicitly related to things like network or storage or applications, but are more concerned about the actual underlying controls that make all of that happen. So the first vertical architecture that I want to talk about is logging architecture. And as you deploy more and more devices and more components to a given ecosystem, you have a lot of telemetry and a lot of logging that is coming out of every single component. And it becomes almost impossible to monitor every single component individually. So what you need to do is create some kind of way to bring all of that telemetry and all the logging into a centralized repository for analytics, as well as for alerting and other types of actions that can be used on that particular data set. In many ways, logging is like a data architecture. Logging would be almost a specific kind of use case for a data architecture, and many of the same principles that apply to data architecture apply to logging architecture. So you might have to build out a storage architecture that goes along with your logging architecture. So logging is going to be concerned about taking logs from all the different kinds of devices and all the different kinds of systems that are in play, pulling that into a central repository, giving you a tool that you can use to correlate those logs, to analyze those logs, and then you're also going to be wanting to feed those logs into other systems that are going to be consuming them for doing things like alerting or threat detection or automations related to events in a system. All of these are part of a logging architecture, and if you're going to be using logging at that level, you want to be able to document that in a way that shows where the data comes from, how the data is being stored, how it's being transformed, and then how it's being consumed. And all of that is part of a logging architecture that you need to consider, especially if you're going to be going into the cloud and how you're going to build that out on the cloud. So automation architecture is another one of those vertical architectures that stripes across all the various horizontal architectures that we talked about. And it concerns itself with how various systems get deployed through automation. And automation is a big part of any modern cloud infrastructure. So this is really going to concern itself with where the assets reside, such as where does my code reside, where do my deployment scripts reside. Part of that might be testing. Another part of it might be deployment pipelines that take those scripts and that code and takes it from the repositories, does builds against it, or does deployments against it, and then ultimately hooks it up to logging. And then there's a feedback loop from that has things like, how do I take incidents that happen in my environment and get those back into my automation suite so that my engineering staff can see that and report on it. And then they can also go back and make changes and thus repeat the loop again and again and again, supporting applications and systems running inside of a cloud environment. So automation architecture needs to kind of express that full feedback loop that DevOps is trying to accomplish. So many times you might have someone called a DevOps architect or an automation architect that really is trying to flesh this whole system out, because it's very important to do this, especially if you're going to have highly resilient applications that can be changed and be tested and deployed very quickly in a way that works across a wide range of different kinds of applications and data systems, etc. So the last vertical architecture that I want to talk about is a technical security architecture. Now, this differs from the kind of architecture that is more high level, which deals with policy and procedures that are more about the governance of security. The technical security architecture is getting into how those are actually implemented as technical details. So this is going to be thinking about how things get plugged into an identity management system, such as Azure Active Directory, or how firewall rules are created and managed, such as network security groups or Azure Firewall, or application security groups on Azure. It's also going to be looking at access controls into an environment. So how are those managed? What are the roles and responsibilities, and how are those defined? And then how are threat mitigations managed, and how are threat responses managed? And the way that all of these things work together are going to be what define a technical security architecture. And this is going to show the various components of that. And it's going to show how all of these things are going to be working together, from the logging aspects, from the access control aspects, from the firewalling aspects, and so on, and everything that goes into making security work in a system. So now that we've talked about all of these various technical architectures, I want to talk about solutions architectures for a moment in light of that. Now, solutions architecture, as I said, stripes across various technical domains, as well as some of those vertical architectures that we mentioned. And as I mentioned, the solutions architecture is really focused on trying to deliver a solution to a specific problem. Now, whenever you start to do a solutions architecture, you really want to scope the solutions architecture to a problem statement. And sometimes that problem statement might be very focused on a very specific domain. So maybe the problem statement is, I need to know how to deploy my application to Azure in a network and VM configuration. And so what I'm going to be doing in that solutions architecture is looking at things related to networking, things related to security, things related to infrastructure, things related to other supporting application components. Those all come into play for delivering a given solution for my application. So that is a solutions architecture. However, those solutions architectures can inform more of these technical architectures that we've talked about. So I could take a solutions architecture, and from that, I could abstract from it a domain-specific architecture, such as a network architecture that's going to be more general and not so much focused on a specific solution or a specific problem. So to do a solutions architecture, you typically want to do an architecture design session. An architecture design session really starts with the problem statement. What am I trying to do? And then from there, it tries to focus the conversation on what am I trying to deliver for this particular problem as a solution. And it's going to get to people together that have various technical backgrounds, various business backgrounds, various roles in an organization, and then try to come up with a solution to that problem. And everybody is having a part of that discussion to frame out a solution that meets the requirements from these various domains, as well as drive business value and drive business process and the scope of doing that. So our point of doing an architecture design session is not really to come up with a data architecture. It might be related to that. However, it's trying to think more broadly than a specific domain. So what I want to talk about is how you run a architecture design session and show you what that might look like. And then we'll talk about the implications that has from that architecture design session. As I mentioned, architecture design sessions really focus in on solutions architecture. Now, a solutions architecture is a solution for a particular problem, as I've said. But this particular design session starts with understanding enterprise architecture. Now, an enterprise architecture, again, is those things that inform an application from the business side of things. So we're looking at business process, we're looking at business value, we're looking at things like governance requirements and security requirements and compliance requirements. We're also going to be looking for things that we can use to evaluate a solution through KPIs, for instance. And some of those KPIs might be measured in transactions per seconds or dollars delivered by the system or customers managed by the system, whatever the KPI might be, that we want to use that KPI to judge whether or not this particular architecture is really a success or not, or how we might be able to improve it. And that really just depends on whatever it is you're trying to solve for in your solution. In any case, start with enterprise architecture to understand the business drivers behind the problem and the changes that are needed for that. The next thing you do is understand within the scope of the architecture design session is what is the scope of the ADS. So the scope is going to try to match to the particular problem what kind of technical architecture I need to really be focused on, such as application architecture or component architecture, or maybe it's data architecture, network architecture. Now, solutions architecture itself is not about trying to build a specific kind of technical architecture. However, it might be focused on a specific kind of technical architecture while considering some of these other architectures that kind of play into it. So if, say, I'm building architecture to run an application on Azure. Now, my application in that case is going to be focused on application architecture. Now, related to application architecture, I'm going to need to consider things like network architecture. For instance, if I'm going to be running this application in a secure environment and I need to be able to connect to things, I might be needing to think about data architecture if it's a large application that has a lot of different data systems that is a part of it. But the primary focus of this is going to be application architecture. And that's what I need to really be thinking about as I do my architecture design session, but I don't want to discredit or ignore other kind of architectural domains that we've discussed. So those are the next things that we try to understand from the scope. So we put the scope on around it so that we don't get off on tangents and we try to focus on what we're really trying to build and build solutions for that. The next thing that we try to do is break down the problem into a step-by-step process. Now, the step-by-step process itself is trying to understand this from a business context, because business value is really about trying to deliver value to whoever the end user may be, the customer in many cases. And we want to understand what processes are in place in a step-by-step process so that I can understand how the value is actually being delivered to the end user or the end client, whoever that might be. And understanding this from a business context helps you understand it from that high level so that whenever you go to implement this technically, you can think about it in terms of business process, and it gives you the opportunity to maybe rethink some of these assumptions and systems that exist and current processes, or to try to think about how you might want to reimagine those to make them more efficient or make them more optimized for whatever business problem that you're trying to solve. In some cases, the business value that you might have in a particular architecture design session isn't about trying to re-engineer anything. Maybe it's about trying to do cost savings by migrating applications from on-premise to the cloud. And in such a case as that, some of the business value that you might be delivering isn't so much something that's going to be expressed in terms of particular KPIs. It might just be cost savings that the business reaps from using the cloud versus trying to do something on premise. And so that is still a business value that you want to capture as part of this understanding and understanding the business process so that you're not ignoring various aspects of that as well. And so these are various considerations that you might want to take into consideration in the third step of running an architecture design session. Now, the fourth one is probably the lion's share of what you're going to be doing. Now, whenever you break something down into a step-by-step process, you want to focus on technical solutions and patterns versus technologies. And by solutions and patterns, what I'm talking about is trying to understand the problem from a patterns and solutions perspective without getting into the particular technologies that might implement that. So if I'm thinking about building a data system, I need particular things to happen in my data system. I don't want to think about this in terms of SQL Server. I want to think about this in terms of the data that I'm going to be moving through my system. It might use SQL Server. It could also use Oracle. It could also use MySQL. The technical details as far as which database it's going to be hosted in may not be a relevant consideration whenever I'm trying to focus on a solutions architecture. And in some cases, the solutions architecture might be bounded by a specific technical requirement. Oh, it needs to run on SQL Server. But even in that case, sometimes the technical architecture doesn't really need to be informed. It just needs to know that it needs to run on SQL Server. And that's fine. There's a lot of options for SQL Server on Azure. I don't need to get prescriptive at that. I just need to know that it's SQL Server, and that's what I'm going to use as part of my solution. Now, the technical implementation of that might vary. I might need to use one tier versus another tier. That's kind of outside the scope of a solutions architecture. A solutions architecture is trying to just say, I need SQL Server in this solution. I'm going to use SQL Server, therefore I'm going to define that. If I'm not prescriptive, it's better to not be that prescriptive even. It's just say, I need a database. I need a relational database here for this particular data. I need a data lake for this kind of data. I need a file store. But there's a lot of different kinds of ways you can implement that technically on Azure. Without getting into the weeds on that, you want to focus in on trying to provide a solution versus trying to be prescriptive in the technology in that case. And so you try to discuss it around those kinds of details versus trying to get into the weeds and try to figure out a very specific technology. That comes later. Whenever you go offline, you might want to research that. But the solution architecture design sessions are trying to focus in on patterns and solutions versus technology. So that's the fourth step in this. So solutions and patterns, not specific technologies. Then lastly, what you do as part of an architecture design session is you try to take the solutions and patterns, and this is typically done offline, is you try to come up with technical components, specific solution components that can fulfill the technical needs and patterns for the business solution. So the patterns are going to be the things that are expressed in the network and the architecture diagrams, and they're going to be what we're going to be applying. But the specific solution components would be getting into some of those technical details. Okay, in this case, we're going to use SQL Server. In this case, we're going to use MySQL. And then we start to get prescriptive in that regard. And then we try to do some research into understanding a specific technical implementation that's going to best serve the solution or pattern that will drive the actual solution. And that's really where we do that in that last step. So whenever we do an architecture design session, we typically try to plan for a collaborative session that is going to be done online, where we have people working together in a collaborative environment, and we're doing whiteboarding, we're talking through solutions, we're trying to understand problems, and we're talking through the pros and cons and weighing advantages and disadvantages and doing a lot of things like that to come up with a solutions architecture. But then what we do after that is we go offline, and then we typically spend about 1 hour offline doing research and trying to craft technical solutions for every hour that we spend collaboratively building non-technical solutions and focusing on patterns. So doing analysis, research, and building documentation. And so what we typically do with an architecture design session is not a one-off event. This is typically done over a period of meetings. You typically start with an initial meeting. You try to understand the high-level context, and then you go through a lot of the business process and try to understand. You start to weigh the pros and cons, and then you stop, and then you go offline and you do some research, you do some analysis, you do some proof of concepts, whatever that might be, and then you take the output from that, the result, the findings, and then you take those and you present them back to the group and you iterate on it some more to discuss pros and cons, etc. So the goal of an architecture design session is at the end of the architecture design session is that you have a solutions architecture that you have a high confidence is going to be able to deliver in the technical details the solution for a particular business problem that is being brought to bear by that solutions architecture. So all of this working together is really trying to define a solutions for a problem that is informed by business value, but the technical details are really going to be the outcome of that. So we're going from a business problem to a technical solution, and everything in between there is going to be driving some of these other architectures that we've talked about and trying to come up with something that we can use for a plan. So the outcome of a solutions architecture, again, is a plan for taking something and putting it into Azure or putting it into the cloud. And so what we talk about in the next phase of a migration is taking all of this information, all this data that we've gathered, all of this design that we've built, and all of these findings that we've found, and all this experimenting that we've done, and all of these various kinds of data gathering mechanisms that we have done a lot of research and assessment to understand the full scope and scale of everything that we're going to be doing. So what we do next is take all of that. We're very well informed. We have high confidence that we have a solution that will work for whatever the problem is. And now we can go into the planning phase, which is the very next thing that we're going to be talking about in our future videos. So stay tuned for that. And we're going to break down everything that you need to do in order to plan and migration into Azure, and then we're going to actually talk about the various pieces of that in great detail, and then we'll talk about executing a plan, and then taking that plan that we build and executing that migration plan for actually doing the migration from a given on-premise system into Azure or from another cloud into Azure.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.